This is, okay, that first set of instructions work. It's a recipe for a single radical in your equation. Next example, of course, we're going to have 2 radicals, which means that recipe needs to be adjusted. So we have 2 radicals instead of just 1 radical in our radical equation. Okay, step 1 becomes isolate the radicals from each other, because it's just easier if you do it that way. It doesn't really matter which one you bring to the other side. So I'm just going to bring, they're connected by addition. So to undo that, to reverse that, I'm going to subtract the square root of x plus 19 from both sides. Subtract square root of x plus 19. And that leaves me with the square root of x plus 3 on the left side, and on the right side, 8 minus the square root of x plus 19. Okay, so if I were to start writing down my recipe right now, step 1, it looks the same, but we're isolating the radicals from each other if you have 2 radicals. What do you think step 2 is going to be? We got to get rid of the radicals. We got to work towards getting rid of the radicals. So step 2 is going to look the same as before. Square, it's supposed to be a square, both sides. We're going to go ahead and square both sides. Now, you have to be careful here. On that right side, you have to square the entire quantity. So put parentheses around that entire right-hand side. Now, the left-hand side is easy enough. What happens when you square the square root of x plus 3? You get x plus 3. That's the left-hand side. The right-hand side, not so easy. Okay, I need you to understand what you're doing here. You're squaring a binomial-like quantity. It's not quite a binomial because you can't have a square root around an x for it to be a binomial. But it has 2 terms in it, right? 8 and then the negative square root of x plus 19. Those are 2 terms that you're squaring. So this is kind of like that equation. A minus b, or that formula, a minus b quantity squared on the left side. What's acting like a? 8. No, you're thinking of the wrong thing. So a minus b quantity squared, what's acting like the a? It's the 8. What's acting like the b? It's the entire square root of x plus 19. Okay? And so this formula, remember, says that a minus b quantity squared is a squared minus 2ab plus b squared. And I'll write it down. In this case, a is 8 and b is the square root of x plus 19. And so we're going to use the right-hand side of the a minus b quantity squared formula to go ahead and write down what that quantity squared, that right-hand side of the equation should be when you square it. So you got a little jump start there. So what should the first term be? When you square the a, what do you get? 64. That's a squared. So we're filling in this part of the formula, you guys. Minus 2ab. Minus 16 times the square root. Good. So minus 16 times the square root of x plus 19. And then, okay, that's the middle part. And then plus b squared. What happens when you square a square root? You just get x plus 19. You could leave it like that or put it in parentheses to emphasize that's, okay, the square root disappeared and it was grouping x plus 19 together, but those parentheses aren't really necessary anymore. Okay, what's the alternative to using that formula? Well, I mean, you could have just written down, and this takes a lot longer, which is why I don't teach it this way, but you could have just written down, you're squaring x minus the square root of x plus 19, so you could have just written it down twice, like that, and FOILed it out, first, adder, and last. But that takes a lot longer than using this formula that you really want to memorize this formula because it does come up in these situations. And it makes you less likely to make mistakes if you know how to use it. All right, so notice what we did. We squared both sides, but we didn't get rid of all the radicals. We got rid of one radical. We still have one radical left, don't we? But that's progress. That's progress. So what we need to do now is simplify and then isolate the remaining radical. So let's make that a separate step, and then we're going to square both sides again. So I'll just say isolate the last remaining radical. So how do we do that? How do we work towards that? We've got to simplify first. We have x plus 3, and then on the right side we have 64 plus, what do we have, 19? 83. And then any other like terms? So these guys combine together to make, I'm not crossing them out, but I'm trying to make it easier on the eyes. So these guys combine together to make 83, right? And then what do we have left? A minus 16 times the square root of x plus 19 plus x. Okay, now I want to work towards isolating the term with the radical in it. So what could I subtract from both sides? Yeah, so I'm going to go ahead and subtract the x's, line them up, and I'm also going to subtract 83 because I'm isolating the term with the radical in it. Okay. And if I do that, what do I get on the left side? The x's go away. What do I get? Negative 80. Oh, that's interesting. Equals, okay, gone, gone. Negative 16 times the square root of x plus 19. Everybody buy that? So that was step 3. We isolated the last radical. Let me shrink this other stuff down. Question?
Does it not matter which variable you're isolating initially?
Which radical? No, it doesn't matter. No, not at all. Now, okay, notice I still have a negative 16 attached as a factor to my radical. You don't have to get rid of that if you don't want to. In this case, it makes sense to divide both sides by negative 16 because negative 16 goes into negative 80 evenly. You don't really have to. At this point, because the operation between the negative 16 and the radical is multiplication, you could square both sides. You'd have to remember to square the 16 as well as the square root, get rid of the square root. You could do it. However, I noticed that negative 16 goes into negative 80. So I'm going to simplify by multiplying both sides by, or dividing both sides by negative 16, or multiplying by 1 over negative 16 if you like. And then it just makes it simpler to deal with. So this was just not necessary. It's just simplifying in the usual sense of clearing out like factors, as you've seen me do before. So what's negative 80 divided by negative 16? 5 equals just radical x plus 19. And that does make it look a little easier on the eyes, doesn't it? So we isolated the remaining radical. That was step 3. What do you think you could guess what step 4 is going to be? Square both sides again. That's supposed to be a square. It doesn't look much like one. It's going to be square both sides again. So if I do that, what do I end up with? So, yeah, or, okay, 25 equals x plus 19, but if you like, turn it around. X plus 19 equals 25. So what does x equal? 6. Okay, so we kind of worked that last step in there. Solve. And then there should be one more step, I guess. What would that be? So step 6 we could call check. Check for extraneous solutions. We'll do that in a second. Does everybody understand steps 1 through 5? So symbolic gymnastics is what you're doing right here. All right, so let's check the answer at least mentally. Make sure it's not an extraneous solution. So if I plug in 6 right here, so x was supposedly 6, I get the square root of what? 9, which is 3. If I plug in 6 right here, I get the square root of what? Which is, does 3 plus 5 equal 8? Yep, check. So yeah, x equals 6, checks.